Hi everyone, welcome back to a new video, and topic of the day is vPC. So in this video we're going to cover vPC. vPC stands for virtual port channel. Alright, so vPC is used on Nexus switches, Cisco Nexus switches, and here our agenda is to discuss vPC theory part, plus as well as we'll have the practical. So we'll see how to configure vPC on Cisco Nexus switches and what difference does it make. But before starting with vPC, let's understand that why do we need vPC at all. Then we'll discuss about the benefits of vPC. So as you have learned about Ether channel in our CCNA or CCNP, that what is Ether channel. So as we know in Ether channel, it is a link bundling technology, allows us to bundle multiple physical interfaces together. By doing this, we will be able to utilize all available physical interfaces, because otherwise you know that STP is going to block them in order to prevent loops. So if we have two switches, switch 1 and switch 2, what we did, we have connected multiple interfaces between these two switches because number of users is high, right? And because of this, we are facing oversubscription issues. So if we'll just connect one interface, we don't have redundancy. If we connect two interfaces, one of the interface will be in blocking state. So we thought, okay, by adding more interfaces, we can have more bandwidth. But STP is laughing at us. STP is saying, okay, let's them add more interfaces and I'm gonna block all of them except one physical interface, because one interface will become the RP and that interface will be used to forward traffic. So in this case, by default, the switch will be acted as the root bridge and this is the non-root bridge. So all of the interfaces of switch 1 will be acted as DP, 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 DP and DP, and this port is going to be RP and the rest of the interfaces are alternate, and alternate interfaces always remain in blocking state. Because of this reason, we'll not be able to utilize the bandwidth of these three interfaces. Only one interface is useful. So we'll bundle them using the Ether channel, and once we'll bundle all these interfaces, these physical interfaces will be represented using a logical interface or virtual interface, which is known as port channel. So now we'll have switch 1 and we have switch 2. Physically we have four interfaces, but virtually there will be just one interface between switch 1 and switch 2, and this interface is known as port channel. This interface is known as port channel. STP cannot block it because logically just one interface is there. So this interface will become DP, this interface will become RP. Even switch 1 is the root bridge. Now we can utilize all available interfaces using the load balancing algorithm, but we are not talking about Ether channel here. Our topic of the day is vPC. But why do we need vPC here, right? So there's a condition for Ether channel, because in real-time networks, as we know that we are following an architecture known as access and distribution layer architecture. So in access and distribution layer architecture, the distribution layer switches are connected to the access are connected to the distribution, but access to access connectivity is not allowed. So let's say this is my distribution 1, this is my distribution 2, this is our access 1, and this is our access 2 switch, and users are also connected. Users are connected with access 1 because endpoints always connect to the access layer switches. This is the connectivity. Now again we are running the spanning tree protocol here. So this is the root bridge. Let's say all interfaces will be designated port, designated port, designated port. This is RP, this is RP here, this is RP. Guys, our agenda is not to discuss spanning tree protocol and its selection. So two interfaces will be the alternate port and they'll be blocked. So again we are not able to utilize all available bandwidth. So we'll think, okay, let's do one thing. Let's bundle these two interfaces together. and let's bundle these two interfaces together. But that's not allowed. There's a very simple condition in Ether channel. If you're gonna bundle two interfaces or more than two interfaces, they must be connected to the same switch on the other side. But here, one interface is going to distribution 1 and another interface is going to distribution 2. So we cannot bundle these two interfaces together. So in enterprise network, we are using a technology here known as virtual switch stacking, VSS. In that, we'll do what? We'll make sure that the two physical switches also appear as one virtual switch or one switch. Once they'll appear as one switch, then we'll be able to bundle this. But in Nexus switches, we are following an architecture known as spine and leaf architecture. So this is my Nexus switch. We are not talking about catalyst switches here. We're talking about Nexus switches. So in Nexus switches, we have an architecture known as spine and leaf architecture. Spine switch is connected to leaf switches connected to spine. Spine to spine and leaf to leaf connectivity is not allowed. So let's say this is my spine 1 and this is my spine 2. Here we have leaf 1 and this is our leaf 2. So we have spine switches and we have the leaf switches. Then we have server connected to the servers. We have servers connected to the leaf switches here. Now again, I want to do what? I want to bundle these two interfaces together. Bundle these two interfaces. But on top of it, we have two different switches. So now vPC allows us to do what? vPC will allow us to bundle these two switches together. Not physically, but virtually they'll be bundled together, and this will be known as a vPC pair. Virtual port channel. So in this case, first of all, I'll make them appear as one switch and then we'll be able to bundle the downstream interfaces or the interfaces connected on the leaf switches towards the spine switches. These interfaces can be bundled now. So this is the end of vPC here. Okay. So let's see here what vPC do. In this case, guys, we are working on Nexus 9000 series. Okay. So a virtual port channel allows links that are physically connected to two different Cisco Nexus series devices to appear as a single port channel to a third device. The third device can be a switch, it can be a server or any other networking device that support link aggregation technology. So what are the benefits of vPC here? It eliminates spanning tree protocol blocked interfaces because now there's just one interface and that is bundled. Uses all available uplink bandwidth. Allows dual home server to operate in an active mode. So this is not just limited to the switches connectivity. Even in data center, we can have the switches who are dual homed. Dual home means that this is a server and this server is connected with leaf 1 as well as leaf 2. By default, the interfaces of this server will be acting as active standby because they are connected to two different switches. But the server also support link bundling. So first we'll make sure that these two leaf switches appear as one switch, and then we can bundle these two interfaces on server side also. So this is not just limited to the switches. Allows dual home means connected to more than one leaf switches and operate in active mode. Provide fast convergence upon link or device failure because now we have device level redundancy as well as link level redundancy. Offer dual active default gateways for server VPCs. Also leverage native split horizon loop management provided by port channeling technology. So it means that we are still having the chances of loop, but we have a split horizon loop management. Because as we know, even in case of Ether channel, the rule is if you have bundled interfaces together and they appear as one, so a message sent to this interface, switch will say, okay, I'm receiving a message on this interface, but this interface is part of a port channel. So I cannot forward this same packet on these three interfaces who are also member of the same port channel. This is the split horizon rule in Ether channel. The same applies to VPC. By using VPC, users can get Immediate operational and architectural advantages as follows. Simplified network design, built highly resilient and robust layer 2 network. Enable seamless virtual machine mobility and server high availability clusters. Scales available layer 2 bandwidth and also increase bisectional bandwidth here because we have full bandwidth available for us and we can utilize all of the links to forward traffic. Grows the size of layer 2 network. Means you can simply grow the size of layer 2 networks without being concerned about spanning tree and all, because none of the interface will be blocked. All interfaces will be useful now. So if you look at this is the physical topology. I have Nexus switch here, Nexus 1, we have Nexus 2 and Nexus 3. So physically the topology will look like this. My switch is connected to this switch and this switch. Normally we cannot bundle these two interfaces together. But once we'll configure the vPC, the topology will look like this. And then it is bundled in a port channel, which can be bundled together and we can utilize all available interface for traffic forwarding. So this is the physical topology on the left hand side, and on the right hand side we have the logical topology. Okay, we have the logical topology. So this is the benefit of using vPC here. Next thing which is very important is vPC building blocks. vPC building blocks. How we are going to build vPC and what kind of configuration is required, and as well as the components you can say. So when we configure vPC, we have components like vPC domain ID, vPC keep live link, vPC peers, vPC peer link, vPC member ports, vPC orphan ports, vPC orphan devices, Cisco fabric services and Cisco fabric services. This is a protocol in the last. Or you can see here as well, in this topology we have two Nexus switches which we're going to bundle together. So very first thing we always define is the vPC domain ID. So I have the tail of the vPC domain ID here. Yes. What does vPC domain ID is doing here? The vPC domain ID groups two Nexus switches into a single vPC domain. So then if I'm going to bundle switch 3 and switch 4, so we will make sure that their vPC domain ID is identical. vPC domain ID 1, vPC domain ID 1. In this case, I've used an example of vPC domain ID 100, but it must be identical on both switches. Then what is the range of vPC domain ID? The range is 1 to 1000. We'll also verify this detail at the time of the configuration. Domain ID must match on peer switches, but domain ID must be unique within the network. Let's say I'm going to bundle switch 3 and switch 4 inside one vPC domain. Switch 1 and switch 2 another vPC domain. So I can't use vPC domain ID 100 and vPC domain ID 100. So there are chances of conflict. That's why if you're creating multiple vPC domains, make sure that they're using unique domain ID. But the switches who are part of the same domain must have the same domain ID. Must have the same domain ID here. Please remember this. After that, if we look at the topology again, we'll discuss about this part also. Here, between these two switches, we have connected two interfaces, and these two interfaces are also bundled. So this interface is known as peer link. And whenever we see the vPC diagrams or vPC topology, we always see two interfaces used as a peer link. Is it a condition? No, it's not a condition. It's a recommendation. Okay, you must use at least two interfaces as a peer link. But if you have a standalone interface, a single interface, okay, it can work. There is no such condition that you have to use two interfaces. Only one interface can be used. But for high availability, we are supposed to connect at least two interfaces as peer link. And then when you are using multiple interfaces, then you have to bundle them in a port channel. So what is the VPC peer link is doing here? VPC peer link synchronize layer 2 control plane information between the VPC peers, because this is part of the VPC domain. VPC domain 1, VPC domain 2. Peer link must be configured as a trunk port because we have multiple VLANs here, information of multiple VLANs and all. CFS protocol, Cisco Fabric Services protocol is used or using peer link to share MAC address table, ARP table, STP states. So basically, if traffic is being forwarded through this Nexus 1, let's say, and the response is coming back from Nexus 2, Nexus 2 will say, I don't know about a user with MAC address A because traffic was forwarded through Nexus 1. That's a challenge. That's a problem here, right? So we want this. That's why we always make sure that they synchronize their MAC address table, ARP table, STP states and all. And who is going to do this? The CFS protocol, Cisco Fabric Service Protocol, is going to synchronize this thing. So this is the protocol sending CFS updates between the VPC peers using the peer link. Recommended to connect minimum 2 links as a peer link, but again it's not a condition, it's a recommendation here. Peer link is supposed to have 10 Gbps of bandwidth in order to avoid congestion, because this is very critical from the VPC point of view. That's why we don't want any kind of latency on this peer link. That's why it is always recommended to have at least 10 Gbps of the interfaces between Nexus, which is used as a peer link. So we have to make sure that the bandwidth of the interface is 10 Gbps. At least 2 interfaces. Even one interface can work, but it's always recommended to use at least 2 interfaces here. Then again, if we go back to the topology, we see we have discussed about VPC domain ID, VPC peer link, VPC peers. Switch 1 and switch 2 are VPC peers of each other, right? Then we have VPC peer keep live link, very important. And in this topology, you will notice something special about keep live link. So you notice this interface is going to a layer 3 cloud, on this also connected to layer 3 cloud, and this interface is used as a keep live link. So VPC is using a layer 3 interface to check reachability over a layer 3 network. That's why the keep live link is always configured with an IP address. It's always a layer 3 interface. It is always a layer 3 interface. Here you can see VPC peer keep live link. What it does, check the liveliness between 2 VPC peers encapsulated with UDP, user datagram protocol. It is sending periodic messages between switch 1 and switch 2. So at the time of the configuration, we'll discuss about the timing and all. At the time of the configuration, we'll discuss about the periodic time, the timeout and all. Management interface is recommended, or you can see management interface is used as a keep live link by default. Management interface is used as a keep live link by default. And guys, I would like to mention one thing here. If you are practicing on eVenchi, so most of the time we are doing practical on the eVenchi, you will connect any other interface and you will use that as keep live link. It won't work. Inside eVenchi, please remember to use management interface as a keep live link. But in our real Nexus switches, they support other interfaces also. Other interfaces can be used as keep live. But in case of eVenchi, please use management interface as keep live. Otherwise, your peer link will say down status, and keep alive link status will also be down. So here we have to use the management interface as keep live link between these 2 switches. And even if you look at my topology, this is going to be a topology here for the configuration. We have connected a management interface. This interface will be used as keep alive. This interface will be used as keep alive. And Ethernet 1/1 and 1/2 peer link. Ethernet 1/3 is going to be part of the virtual port channel. This is going to be our topology here. But before that, let's talk about the components. VPC peer keep live link. Let's go back to the diagram. So VPC domain ID, VPC keep live link, peers, peer link, member port. This interface and this interface is going to be bundled because these two interfaces are going to this downstream switch. So they are going to be bundled in a virtual port channel. So they are known as member ports. They are known as member port. But if you have started using VPC in a network, it doesn't mean that you have to use VPC for all the links. You can have an interface which is not part of the VPC. So this interface is known as orphan port. As its name suggests, orphan port. And any device connected to this orphan port is known as orphan device. Any interface connected to this orphan port is known as orphan device here. So this interface will be known as orphan device. This interface will be known as orphan device, and this interface is known as VPC member port. So VPC member port, orphan port, orphan devices. Last but not the least, we have Cisco Fabric Services. This is a protocol which is playing a very important role in VPC. And as we have the discussion here, Cisco Fabric Services, Cisco proprietary, by default it is enabled on VPC peer links. It is responsible to synchronize configuration and state between VPC peer switches. You cannot manually disable CFS for a VPC, guys, because it's by default enabled and we can't disable it. If we want to disable, still we cannot disable Cisco Fabric Services protocol between two VPC switches. So Nexus 1, Nexus 2, CFS is running and advertising the information. Advertising the information related to the MAC address table, ARP table and all. So they are the building blocks of VPC here. Each component has a meaning. On the spine switches or leaf switches, spine switches, when we'll create the VPC, we'll run a command here, show VPC, and this VPC command will give us a lot of output. But right now just focus on one thing. Focus on VPC domain ID and see VPC keep live status. Peer is alive. But this will show you as alive only if you are using management interface as a keep live in EVE-NG. In our real Nexus switches, you can use any other interface also, but here we have to use the management interface. Peer status, peer link is not configured at this moment when the screenshot was taken. We'll discuss about it and we'll see how to make the configuration. Then we have to make sure of, before talking about the parameters, just there are two types of VPC we have, single-sided VPC and we have double-sided VPC. So in case of single-sided VPC, switch 1 and switch 2, they are running VPC domain ID 1 and they are bundled together. But they are the individual switches and then also a server. On this side, guys, this is not known as a virtual port channel. This is a normal port channel. Nothing special about this. But on the switches side where we have used VPC, all these interfaces are bundled together and they are known as a virtual port channel. And when we'll make the configuration, you will notice that we have to execute a special command on this. First we create a port channel, normal port channel using LSEP, but then we'll convert it to VPC, virtual port channel. This is a single-sided VPC. We can also have double-sided VPC in this case. You see, these switches are bundled. These switches are also bundled. In this case, you notice 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 interfaces are connected. But this VPC allows us to bundle up to 32 member ports in a single port channel. So this is known as double-sided VPC. Then we have two types of consistency check between VPC peers. Type 1 consistency check, type 2 consistency check. So here we have the output using a command known as show VPC consistency parameters global. So you see type 1 VPC will be suspended in case of mismatch. That's why we have categorized them as critical. Second is we have type 2, they are non-critical. So in case if they mismatch, still VPC will remain in up state. VPC will remain in up state. So global VPC parameters, the VPC domain ID must match. Role priority configured separately. Peer keep live status should be in up state. STP settings, spanning tree mode. If you're running RSTP on Nexus 1, you must be running RSTP on Nexus 2. Port channel settings, if you're using LSCP or manual method. Interface parameters, VLAN allowed list, MTU, trunk native VLAN configuration, as well as VPC system MAC or system priority must match for proper LSCP negotiation. That's why they are considered as type 1 consistency check. Then we have type 2 consistency check, non-critical. Interface settings, IGMP snooping multicast, port security storm control, STP timers, VLAN membership, means non-VPC VLAN zones. They are known as the non-critical consistency check. After this, we have the configuration of the VPC. How we make the configuration? First of all, in real-time networks, we have to check the NXOS version. It must support the VPC first, right? Connectivity must be there. First, build the physical connectivity. Once the physical connectivity is up and working, then we can go for VPC configuration, and proper licensing must be there. If first step is done successful, then we can go to the second step. As we know, in case of Nexus switches, let's say if you just want to configure OSPF in normal devices, in case of Catalyst switches, what we do if we want to configure OSPF, we just simply say router OSPF1 network, you put the network ID, then you put the wildcard mask, area ID, and exit. But in case of Nexus switches, first you go to the configuration mode and you say feature OSPF. First you have to enable the feature of OSPF on the Cisco Nexus switches. Then you can start making configuration of the OSPF. Then you can start making the configuration of OSPF. Likewise, when you want to configure VPC here, you have to enable feature VPC. To bundle the interfaces, we are using LSCP protocol. We don't have PAGP on Nexus switches, guys. We learn about PAGP in Catalyst switches, port aggregation protocol and link aggregation control protocol. We have two protocols, PAGP, LSCP, and we have own method, manual method. But here PAGP is not supported. Then feature interface VLAN. This feature needs to be enabled only if you are using an SPI as a peer-keepalive link. So in this case, we're gonna use management interface as a peer-keepalive link. So we don't need to enable this feature interface VLAN concept here. Configure VPC domain and role priority. Configure VPC peer-keepalive link. Configure VPC peer link. Configure VPC member port channels, and then you can have the verification of the configuration using show VPC brief, show VPC consistency check, show VPC peer-keepalive. All these commands are there, and then you can save the configuration. So if you go step by step, it's best. We have very low chances of making any misconfigurations, right? Very low chances of making misconfiguration. So you can go for the configuration step by step. So we'll make the configuration of this VPC on our Nexus switches. So let's get ready with the lab first, the Nexus switches, and then we'll start with the command line. Let's see the configuration of VPC here. So this is my first switch. First thing we'll do is we'll configure a host name. Let's say NXOS1. Host name configured. Then we have the second switch. By default, username is admin and password is null. So you just say admin, okay? And when it asks for the password, we'll say enter. Because by default, the username is admin on Nexus switches and password is null. Configuration mode, host name, NXOS2, host name configured. Now we'll configure this third switch also, but for right now, we'll just configure the host name and then we'll leave it. We'll come to this switch at the last when we have to configure the port channel. First of all, we'll be making configuration on our Nexus OS1 and Nexus OS2. Let's configure the host name on this switch and leave it. Configuration mode, host name, NXOS3, exit. Let's come back to NXOS1 now. This is my NXOS1. As we have seen it here, the first thing we'll do is we will be configuring a feature VPC. Feature VPC. Guys, you can enable LSAP later, right? But you can also enable LSAP at the same time. You can say feature VPC and feature LSAP. Let's open both switches, NXOS1 and NXOS2. We'll make the configuration on both of them together. NXOS2. So like we have enabled LSAP feature and VPC on switch 1, likewise we'll do on switch 2 also. Feature LSAP and feature VPC. After enable this feature, we'll configure a VPC domain ID. And like I said, the range of the VPC domain ID is 1 to 1000. So let's say VPC domain 1. Here also we'll say VPC domain 1. The domain ID must match. The domain ID must match. Inside this VPC domain, we will be configuring VPC peer-keepalive link. Peer-keepalive, it will ask us the destination IP address. But if you notice, we haven't configured any IP address on our Nexus switches. So we'll go to the management interface and we'll configure an IP address on both of them. Let's configure an IP address here, interface management 0. IP address, we are using a subnet of 10.1.1.1/24. No shutdown. Because for the keep alive, it's a layer 3 connectivity. So we will be using IP addresses to reach each other, and that's how we verify that our device or our VPC peer is alive or not. So here again, interface management 0. IP address is 10.1.1.2. 255.255.255.0, no shutdown. You can check the reachability also. You can say ping 10.1.1.1 VRF management. First packet drop because of the ARP request, then we can see ping is successful. So from NXOS2, I'm able to ping NXOS1. Let's come back to the VPC domain now. VPC domain 1. Peer keep live destination. So NXOS1 will go to NXOS2. So the destination IP is going to be 10.1.1.2. Source IP. Guys, at this point, this command doesn't make any sense. The source command doesn't make any difference because we're going to use the management interface. But in real switches, when you want to use any other interface as a keep alive rather than the management interface, that time you'll use this IP source 10.1.1. So whatever interface you want to use in that case, you can put the source IP address of that interface. But here we are allowed to use the management interface only. In case of EVNG only, okay, VPC domain 1, peer keep alive destination 10.1.1.1 source. From R to the source is going to be 10, sorry, Nexus 2. Source IP is going to be 10.1.1.2. Once you configure this, we haven't configured peer link and all. We have just configured the keep live link. Let's check the output first. Show VPC peer keep alive. You can see that peer is alive. Now peer is alive. Send status successful. Receiving status also successful. Interface we are using at the moment, the management interface for sending the packets and for receiving the packets. Destination IP is this. Keep live interval 1000 milliseconds. So in every 1 second, the Nexus switches are sending keep live messages to each other in every 1 second. Let's go to the configuration mode and now we'll configure peer link. VPC domain configured, feature enabled, and keep live link is also configured. Now we'll configure the VPC peer link. So first of all, we'll say interface Ethernet 1/1 to 2. In Catalyst switches, we have to say interface range, but in Nexus switches, range keyword is not required. You can simply say interface Ethernet 1/1 and 2. You can say no shutdown. Channel group 1 mode. Active. I'm using LSCP. Now you go to the interface port channel because we are using two interfaces as a peer link. Port channel 1. This peer link must be configured as trunk. That's a condition. Switch port mode trunk. Switch port mode trunk. Likewise, go to the Nexus switch 2 interface Ethernet 1/1. If you're using just one interface as a peer link, you'll just go to that interface. You don't need to create a port channel. But here we are using a pair of interfaces as a peer link. So first we have to bundle them in a port channel mode active, no shutdown. Once you do that, go to the port channel here, interface port channel 1, switch port mode trunk. Now, right now, this interface is just like a normal port channel because this is what we're going to use here, right? But this needs to be configured as a peer link. And in order to do that, we have a command here. VPC peer link. So I'll go to Nexus 1 first. This port channel is here for peer link. We're going to use this interface as peer link. VPC peer link. VPC peer link. Exit. Exit. Now NXOS 1, NXOS 2. Show VPC. VPC domain ID is 1. Once you configure the peer link, please verify this peer status. Peer adjacency should be up or peer adjacency formed OK. If you see that there's a problem, then you have to troubleshoot it first. First of all, they must be the peer of each other. VPC peer adjacency formed OK. Domain ID 1, peer is alive. And then the port channel 1 is the VPC peer link. Port channel 1 is the VPC peer link. Show VPC. Earlier the consistency check was not performed, right? It was showing that consistency check not performed. But you see now configuration consistency check status is success. Type 2 consistency status check is success. Type 1 also successful. Here is the type 1. Okay, and this is the type 2 successful. It must be up here. Then notice one thing. If I say show VPC domain ID 1, sorry, show VPC row In VPC, we have the role of primary and secondary. One of the switch will become the primary. In this case, our Nexus OS1 is selected as primary and Nexus OS2 is selected as secondary. So the VPC primary and secondary election is based on a parameter. It's similar to STP root bridge election. It is similar to STP root bridge election. We had the properties here. No? Okay. We're having a note related to this election. Otherwise, I'll explain. Let's find that out. Okay. Here it is. So VPC primary election is based on VPC switch priority, but by default priority of each switch is 32667. 32667. Then lower value is equal to higher priority. Lower means higher. So if switch 1 priority is 0 and switch 2 priority is 32667, it means 0 will get more priority. If the values tie, then lowest MAC address. Lowest MAC address, similar to root bridge election. So in this case, we have Nexus OS1. If we run the command show VPC role, here also I say show VPC role. Show VPC role. VPC system MAC. The local system MAC. VPC local system MAC 5001000001B08 and VPC local system MAC is 5002. So guys, 5050. We check it from left to right, then 01, but here we have 02. So it means 01 is the lowest MAC address. That's why NXOS1 is elected as the primary and this NXOS2 is elected as the secondary. But if you want to change the priority, you can change it. You need to go to the VPC domain ID and there you can change the priority value. Done. We have just configured VPC keep-alive link, VPC domain and VPC peer link. Now it comes to bundle these interfaces, Ethernet 1/3, Ethernet 1/3. But they are part of two different switches. No problem. Now they both acting as just one switch. So we'll go to spine 1, or you can say Nexus 1 and Nexus 2. On Nexus 1, go to the configuration mode. Interface Ethernet 1/3. Channel group 100. Mode active. Please don't use channel group 1 because we have already used channel group 1 for peer link. Interface Ethernet 1/3. Channel group 100 mode active. Till now the configuration is identical. Then you'll go to interface port channel 100. This is also connected to the downstream interfaces and we are using VLANs. So we'll configure this link as trunk. Switch port mode trunk. On NXOS2 also we'll say interface port channel 100 switch port mode trunk. Done. This time the link type is not going to be peer link. It is going to be a VPC, and for that we'll go to this interface and we'll say that this interface is a VPC. VPC 1. Interface port channel 1 VPC 1. Oh, sorry. Interface port channel 1, not 1, sorry, don't make this mistake. Interface port channel 100 VPC 1. Port channel 1 is used as peer link. Interface port channel 100 VPC 1, because this is the virtual port channel. So it means Ethernet 1/3 is the member port. But if you notice, show VPC, port channel 100 is in down state yet. It will remain in down state until unless we go to this Nexus 3 and we configure these interfaces inside a port channel. Only then this VPC will come up. So let's go to this switch. Here we are not going to enable VPC and all. We'll just enable LSCP feature. Feature LSCP. Interface range. Sorry, no, range keyword is not required. Ethernet 1/1 to 2. Channel group 100 mode active. Exit. Show ether channel, sorry, show port channel summary. Now you can see that S means layer 2, U means in use. Used protocol LSCP. And once you make configuration on this switch, if you go to the VPC switches now and you run a command show VPC, so you will notice that our port channel 100 is in up state. You'll say, okay, how you'll check that both of the switches are acting as just one switch? So go to Nexus 3 and run a command here, show LSCP neighbor. So in show LSCP neighbor, you will see the same switch ID 0234 EEBE1 0234 EEBE1. On which interface? Ethernet 1/1, Ethernet 1/2. You will see the same as show spanning tree. You see who is the root bridge. This is the address of the root bridge. This is the address of the root bridge in this topology. This is the address of the root bridge. So now both of the upstream switches are acting as just one switch. They are acting as just one switch, and we can notice there's a type inconsistency because on the upstream switches we have configured the interfaces as trunk, the port channel, but here it is an access port. Interface port channel 100, switch port mode trunk. We have configured that port channel 100 as trunk on the VPC domain, right? So here also you'll configure it as trunk. Then you'll say the type inconsistency port is removed. Port channel 100. It's up and running. So that's how we can configure VPC, and both of these switches will be acting as a single switch. Otherwise, you notice that these two interfaces are going to two different switches, but still they're bundled together. There's no challenge in that. It is only possible because of virtual port channel here. Now when you make this configuration, what should match between two switches? On this side, if I'm using Ethernet 1/2, am I supposed to use Ethernet 1/2 here? No, it can be different. Port channel number must match. If you say port channel 100 on this side, it must be 100 on this side. VPC number must match. Like let's say we said VPC 1. Here you can't say VPC 2. You have to say VPC 1 here. Physical port numbers can differ. Ethernet 1/2, Ethernet 1/3. VLAN trunking and LSCP mode must match across both peers. These things must match when you make the configuration of the VPC port. So in this case, the 1/2 is the member port, and on this switch 1/3 is the member port. Okay. Keep live link configuration. Then there are timers in the keep live. Keep live interval, which is 1000 milliseconds, or you can say 1 second. So in every 1 second, the switches are sending keep live messages to each other. Keep live timeout is 5 seconds. It is similar to let's say OSPF. I'll send you message in every 10 seconds, hello message. And I'll wait for 40 seconds to declare you dead. So if I haven't received any message from you from last 40 seconds, it means you are not alive. Likewise, here we have 5 seconds. If switch 1 is sending messages to Nexus 2, switch 1 is primary and switch 2 is secondary. If Nexus 2 hasn't received any message, keep live message from Nexus 1 from last 5 seconds, it will consider to change the role. But it is also giving us extra 3 seconds. Keep live, hold timeout. So there are two timeout guys, keep live time and keep live hold down timeout. So it will say, okay, I'm waiting for 5 seconds. Now let's switch the role. Before switching the role, let's give you additional 3 seconds. Let's give you additional 3 seconds. Keep live interval between keep live packets are sent. Default value is 1 second. Keep live timeout, the time interval to decide the VPC peer is alive or not. And the keep live hold down timeout, the wait duration before declaring peer failure. So we are getting actually 8 seconds, but 3 seconds is the waiting period to declare the neighbor as dead or not. You can change these timers, but not recommended. Let them as it is, okay? We don't need to change them. Show VPC, this is a verification command. You can see one of the switch is the primary, second switch is elected as second. Then VPC role status, we have checked it, and this is the parameters. We can see here. These are the parameters of VPC. So this is all about the VPC guys, VPC configuration as well as VPC theoretical part. So if you guys have enjoyed this video, please make sure that you subscribe the YouTube channel, as well as you can, if you have any query, put it in the chat box. Okay. Alright guys, thank you for watching this video, and I'll see you in the next video.